Today we'll be going to transient analysis, another dimension called AC inputs. The AC inputs means we'll be talking basically two types. AC means sine or cos, and with angle, without angle. So how to really understand the initial conditions and also analyze the circuit. In this we see how the circuit is going to respond to AC inputs. So today this lecture will concentrate mainly on AC. For the illustration I have taken the first problem. Calculate I of t at t0 plus for RL series network. This is the circuit given to us and sin t is the input given. Now please understand, we can never estimate T0 plus without estimating T0 minus. And once again I am repeating for the sake of convenience for people to understand 2 points. Current through inductor cannot change instantaneously, and voltage across capacitor cannot change instantaneously. These two words once again we have to remember. Now let me take you to what to do. I will be doing two steps, T0 minus, T0 plus. First I am drawing a circuit for T0 minus. What do you mean? Switch was open. When switch is open, this inductor is not connected to supply. When an inductor is not connected to supply, it cannot develop any current. So no current is developed by the inductor, so I kept it open circuit. Therefore effectively current at this level is 0. Why the current is 0? Because switch is open as well as inductor is open. Now T0 plus. T0 plus, what happened is the switch which was open circuit here is now closed. But the inductor cannot change its value instantaneously. Therefore, whatever was the current is the same current now. That was open circuit, therefore now also open circuit. Therefore, effectively the current is once again 0. Please understand, we are targeting on objective question exam. Therefore, in objective question exams, they can't give total procedure for 1 or 2 marks. That's why they'll give initial conditions as one problem and other calculations is another problem. That means for t greater than 0, we'll go to another problem. So let's go to second problem. The idea is to calculate I of t for t greater than 0 for RL serial network. This idea is to use the previous initial conditions. So whatever the initial conditions you got earlier, you can use now. But now idea is to calculate I of t. Now look at the circuit. Switch is now closed. Inductor is there. It is neither open circuit nor short circuit. Why inductor is neither open or nor short? Because you are taking for t greater than 0. That means time in general it is neither open nor short. So V sin t, this is the meaning. Now just like an ordinary circuit without switch you analyze. Shall we apply Kirchhoff's law here? Join with me here. V sin t is equal to IR L di by dt. Very simple thought. Then if I take Laplace transform for sine, this is, remember, sin t 1 by s square plus 1. So V into sin t means V into 1 by s square plus 1, R into I of s, L into s of s minus this. This is called differentiation property. Now in the previous problem, we have got it as 0 value. That's why initial conditions or the transients problems we can always keep it as, linked problems. Linked problem means whatever the answer you got in the previous problem will be used as a data now. For example, problem 1, we got I of 0 plus as 0. I'll be using it here. That's called the meaning of linked problem. And after that, if we take inverse Laplace transform, we will get I of t. I am simply saying inverse Laplace transform you have to take because all these procedures will be discussed in signals and system at length. So you have that subject separately so you can solve it. So it is not good for us to solve here. It will take laborious time. But the basic thought we have understood. Let's go to problem 3. Calculate I of t for t0 plus. This also will estimate initial value in one problem. You analyze that in the other problem with this data there. Then what is the difference of my choice here? I have chosen the previous circuit as RL, now the RC. Then input is sine. And please understand, suppose input is cos also you can analyze. The only difference is if it is sine, V sine 0 is 0. If it is cos, V cos 0 is 1. And that means V into 1. Even then, if it is exponential, e power 0 is 1. So, it's simply to say, wherever there is t, put t is equal to 0. Don't be shocked and don't be worried whether it is DC or AC. Only value is t is equal to 0. Now, let us see what happens. At t0 minus, what happened is, switch was open. When switch is open, capacitor is not connected to source. When capacitor is not connected to source, what will happen? Automatically, when capacitor is not connected to source, capacitor could not develop any voltage. It has no privilege of developing voltage. No voltage means 0. 0 means short circuit. Please remember, it is short circuit because it is 0 volts. It is 0 volts because it is not connected to source. That's the way of learning. Otherwise, if you say it is short circuit, open circuit, you will be thoroughly confused and spoil the whole thing. Right. Now, this is the situation for open. Therefore, what is the total current in this circuit? 0. Now, let me tell you what's happening for T0 plus. For example, if T0 plus means what? Switch is closed. These two dots I am just telling you, but switch is closed here. Then capacitor is there as it is. Now, what is the current in this? Actually speaking, circuit is closed. You will be tempted to say there is a current. It is true there is a current, but sine 0 is 0. 0 by R is 0. So, once again, though there is a chance of current flowing because it is closed, still it is 0. It is not 0 because circuit is closed, but it is 0 because input is 0. When input is 0, nobody can help us. Ultimately, current is 0. So, this initial condition we are going to use it in another what you call next problem to estimate the current. So, that is about third problem to say 0 minus and 0 plus. Now, let us go to problem 4. Calculate I of t at t greater than 0. As I told you, I am going to use the same circuit. Why? To save our time and your learning. Your learning also should be brought in a simple way. So, what is that I have already existing? Vc of 0 plus is 0. Look at that. Vc of 0 plus is 0. So, what I do is, we will use the existing things and apply this current. So, V sin t is equal to Ri plus 1 over C integral I dt. Then what will happen? You can directly apply Laplace transform. Please remember, sometimes if you are solving mathematics, you call differential equation V sin t IR 1 over C. What people normally do, they say differentiate it, bring it to the differential equation level. The advantage of Laplace transform is you don't need to bring it to differentiation. You can straight away go for Laplace transform. So, 1 by integration is 1 by Cs. I of s by s. Solve for it, and when you solve for this, you will get inverse Laplace transform, and then finally you will get I of t. The whole idea is how to get the equation, how to solve the equation. As I told you, in objective question exam, they are not asking for I of t, they are asking Laplace transform equation of the circuit. But you have to know initial conditions. Because this initial condition is 0, that's why no voltage is available here. Directly it is taken as 1 by Cs. So that is the meaning of what you call inverse Laplace transform. You will get I of t. That is our fourth problem. Let's go to fifth. Calculate I of t at t0 plus for the RLC circuit. Here what is happening is, what is the difference then? This actually speaking, this is already over in the first problem. But the difference I have created is by keeping angle here. So please focus, in this problem the main is angle. Otherwise, if I make theta as 0, there is no difference between problem 1 to problem 5. So look at that. Solution. T0 minus switch is open. When the switch is open, what happens to inductor? Not connected. Not connected means how much current is developed? No current. So inductor current is 0. When the inductor current is 0, this total angle is V sin t by R. Actually speaking, if you see, there can be a current. Look at my circuit here. Switch is closed. Resistor is here. You are given something, you can put t is equal to 0. There is some value for the input, but because inductor is open circuit, current is 0. So inductor is open circuit, current is 0. So whatever the current was there earlier is now continuing because inductor cannot change instantaneously. Switch position is changed, input value is changed, but inductor is not allowing the current to change. So wherever there is an inductor in series with the circuit, a total circuit depends on inductor. That's about with angle. Now the same thing, what will happen for t greater than 0? That means whatever the initial value that you have, that you supply here. When you supply the initial value here, what will happen? Let us see. T greater than 0. Switch is closed. Ri LdI by dt. V sin t plus theta. What will happen here? Everything will be there. V sin t plus theta IR plus LdI by dt. Now by solving the above equation, we can get the Laplace transform, then inverse transform, and finally you will get I of t. Don't be frightened how to take Laplace transform here. Sin a plus b, you should expand it as sin a cos b minus cos a sin b, like that. Then you apply Laplace transform. So Laplace transforms anyway we will study in signals and system. Here it is to analyze the circuit. Let's go to next problem. Calculate same circuit, RC circuit. When you have an RC circuit here, now what is the change there? V sin t plus theta. As I have been telling, if it is cos, don't worry. If it is cos, you will have cos 0 plus theta. Now sin 0 plus theta, right? Now let me talk to you about two steps. T0 minus, what will happen? Switch is open. Because switch is closed, you have to see the arrow and then find out. Switch is closed only at T0 plus. That means just before 0, it is not closed. So switch is open. Capacitor could not develop any voltage because it is not connected to supply. So capacitor is nowhere connected, no voltage, 0 voltage. Therefore, V sin 0 plus theta. You see how I have written there? Please observe this very carefully. Switch is closed, resistor is here. Capacitor cannot change its voltage separately and instantaneously, Now this is a so V sin t plus theta into IR is equal to this. Now what is the current if you want? V sin t plus theta by R. Now if I substitute t is equal to 0, what happens here? V sin, please observe here, t is 0, therefore only theta. So I am not giving the value here because theta can be any angle. Suppose sin is 0, theta is 0, answer is 0. If theta is 90, answer is V by R. So depending on the angle, it is changing. Please observe my style. I have brought this circuit analysis, particularly transient, into 3 styles. First I took DC input, then I brought T variable, then lastly I am bringing theta variable. So I remember how I am changing this theta variable also into picture. 8th problem. Calculate I of t for t greater than 0 for RC circuit given here. V sin t plus theta. Okay. RC. Slowly observe this. We have to use the initial conditions of the previous. Why? Because this is the same circuit. So use the previous initial conditions, then write. So what happens here? V sin t plus theta is equal to IR plus 1 over C. Okay. Now you have to consider initial conditions of the previous circuit. Please remember there is initial current. So take this equation, take the Laplace, and by taking inverse only you will get I of t. So this is another thing to tell you how to illustrate or how to consider AC input along with theta there. 9th one. Now I am giving a small idea, very interesting idea. This is called single pole double throw. Calculate I of t for t 0 plus. If the switch is at position 1 for a long time and then moved to position 2 at t is equal to 0. Now please observe this circuit. This is the switch. What does he say? He is saying switch is at 1 for a long time. If switch is at 1 for a long time, what are you expecting? If it is at 1 for a long time, whatever the voltage is there, that will come here. That is what happening here. After that, you can push over here, right? So shall we follow this? T0 minus, this is the circuit. When you keep it for a long time, whatever the voltage is there, the maximum voltage will come here. The maximum voltage means what? The maximum value of sine is 1. So Vc into V, so this is total V0 comes here. Now that is applied, you look at here. At t is equal to 0 plus, which is moved here. So whatever the voltage that is developed is acting as a voltage for this. Okay. But unfortunately, when the switch was here, inductor could not develop any current. That's why current is 0. Whatever the 0 current is here, same current is here. Therefore, you have a same conclusion, T0 minus current is 0, T0 plus also current is 0. Though there is a lot of voltage developed here. Because this is open circuit, current is not allowed to change. That's the meaning of what you call integration or initial values. Now what do you guess? Same circuit, I am going to take t greater than 0. Why? In the previous problem, we estimated initial values. Now in the present problem, I am going to estimate actual current. So same problem. Now by giving a position 2, estimate this current. Estimate what is happening there. So you just closely observe. This is position 2. This is available. Why all the inductors and capacitors are available for generally? Because in general time, it is neither short circuit nor open circuit. So capacitor is there along with its value. Inductor is there along with its value. So you will be substituting Ri L di by dt 1 over C, and this also will come. So this is actually not given to the source, but because it is there across the capacitor. So this is acting as whatever the initial value that we counted from the previous, that is produced here. That's why we always say linked problems. Initial value is one problem that is used in general thing. That's why it is always linked. Now for this equation, take the Laplace. Inductor current is anyway 0, but capacitor across voltage there is there, that is anyway taken here, apply. So then by solving this, solve for I of s, then if you take inverse transform, you will get I of t. So these are the definite understandings or illustrations to say how a transient circuit is working with AC, both with angle and without angle. So this is all about AC inputs given to transients, how RL, RLC, all the components are working together. That's the end of this lecture. We will be taking another lecture as a last thing, that is called SPDT, single pole, single throw, how to handle. Whether it is AC or DC, all that we handle there.